talking about some methods you can use to help you in planning your code, essentially getting from that initial problem statement to something you can actually turn into a MATLAB script. So if you think about some of the MATLAB scripts that we've already written, there are kind of three main steps that you'll be dealing with. First, your program is going to take some type of input value, is going to perform some type of processing to produce a desired output result. Okay, so that's the typical sequence that your program is going to go through. However, when you're thinking about creating your program, you might want to think about these in a slightly different order. So the first thing you'll want to think about is the output. What ultimately do you want your program to do? Does it need to perform a computation and give you a value? Does it need to create a graph? Or does it need to do some type of simulation? Okay, so you want to understand what it is that you're trying to get out of the operation of your program. Once you know what you want to get out of it, then you need to figure out, what do I have available for me to get to that desired output? So essentially, what input information do you have available? Do you have a set of data? Do you have some coefficients for an equation that you need to implement and then do some calculations on? Okay, so what are your input values? Once you know what your inputs are and what your outputs are, then you can start to work on, how do I transform those inputs into that output information that I want to ultimately be able to have. So let's take a look at a quick example so you have an idea of what I mean by inputs, outputs, and processing. So here's a problem statement, something you might have seen in a junior high or high school algebra class. Okay, so we have a cattle train, it's leaving Miami, it's going towards New York. A little time later, we have a different train that leaves at a certain speed, and we ultimately want to know what the cattle train's average speed is. So if we look at this problem, if we were trying to do this by hand or write a MATLAB script in order to solve this, the first thing we need to understand is, what am I trying to find as a result of trying to solve this problem? So that's pretty easy. It's that last sentence there. We want to find out what the cattle train's average speed is. So that's our output. What information do we have available to try and calculate that? We have all this information in the problem. We have the diesel train speed, we have the time between the departures, which is 14 hours, we have the time it takes for the diesel train to catch the cattle train of 4 hours. Okay, so those would be our input values. Now that we know our inputs and our outputs, we move to the processing, which is just some basic algebra. You can see the equations there. That part's not really important. The important part is that you see how we look at a problem statement and start to try to identify what our outputs, inputs, and then ultimately figure out what our processing is. Okay, so once we've identified our inputs, outputs, and processing, the next step is to actually describe the steps that are required in order to transform those inputs into the outputs, essentially describing these steps that your program is going to take. So there's two different ways that we can do that, or there's multiple different ways. There's two different ways that we're going to talk about. The first one is called flowcharts. So flowcharts is a graphical way to depict these logical steps needed in order to solve a problem or implement an algorithm. Okay. You should never have any program code in your flowchart. The purpose of using a flowchart is to help you focus on the plan without having to worry about the syntax of whatever the specific language is. So really, a flowchart is a universal tool you can use regardless of what language you're using. All right, and ultimately, if you use it correctly, it's going to help to save you time, both in terms of writing the code, because if you take a little bit of time, think about what you need to implement beforehand, it'll take less time to actually write the code, and also help you when you run into problems that you can go back, look at your flowchart, and figure out what went wrong within the steps that you're trying to implement. Okay, so to create a flowchart, there are a couple symbols that we need to know. So the first is the start-stop symbol. So it's kind of self-explanatory. You're going to have a start symbol at the beginning of your flowchart. You're going to have a stop symbol at the end of your flowchart. Okay, they're pretty much the same thing. We have an oval. We also have what is called a process instruction. So this is any step where you're going to be doing a computation or some type of process within your algorithm. We have what's called the conditional test. You would use this if you're doing a conditional structure like an if or a switch, or if you're using a loop. Anytime that you're asking a question, then you need to perform a different set of actions based on whatever the response to that question is. We have the input-output block, which is a parallelogram. So this is whenever you're asking the user to provide you with values, or if you are displaying some value to the user or outputting something in some way. We have what's called the connector. We probably won't use these too much in this class, but if you're working on a larger scale project and you may have a really complicated flowchart, you may want to break it up into smaller pieces. You would use the connector to say, go from this one flowchart to this other flowchart, and That'll just help you to break it up into smaller pieces. And then the last thing, which is probably the most important thing, is what's called the flow line. So this is what you use to connect each of these different blocks together and shows the direction of flow throughout the steps in the process. Okay, so now that we have a basic understanding of what flowcharts are, let's look at a couple examples so we can see how we create them. So in each of these couple examples that we're going to look at, we're looking at a process of converting a temperature from one temperature scale to another. So say maybe from Celsius to Fahrenheit or vice versa. So here's what we would call a linear flowchart. It's just a straight process. We start, we get a temperature value, we convert it, we display that resulting converted temperature value, and then we stop. Here we have a slightly more complex version of this same basic algorithm. So now, instead of just doing one type of temperature conversion that you saw on the linear flowchart, now we have two different versions. We can do either Celsius to Fahrenheit or Fahrenheit to Celsius. So again, we start, we get our temperature value from the user. We also now get which type of conversion we're doing, so whether the initial value is in Celsius or Fahrenheit. Based on a conditional check that we can do, are we doing Celsius to Fahrenheit or Fahrenheit to Celsius? We do the appropriate conversion, and then we display that resulted converted temperature at the end. And last here we have now a flowchart that has some repetition in it. So you can see the top part is basically the exact same flowchart that we had previously, where we introduced the decision to do Celsius to Fahrenheit or Fahrenheit to Celsius conversion. Now we have another decision block down at the bottom that asks if we're finished. So maybe we have a bunch of temperature values that we want to convert. Okay, so now we can, if we're not finished, we'll go back up to the top and repeat the whole process again. Okay, so hopefully these three short, simple examples give you an idea of how you start to create these flowcharts by putting the blocks on and then connecting them with the flow lines. An alternative method to flowcharting is what we would call pseudocode. Okay, so pseudocode, now instead of the graphical representation we have with flowcharts, pseudocode is a textual representation of the steps required to give out or to perform a specific task. Okay. So in pseudocode, you can have statements that are similar to programming statements. You don't want to actually have code necessarily in your pseudocode, because this is supposed to be planning, not actually writing the program. If you're writing the program, you might as well just go into the MATLAB environment and start writing. Okay, you can have structure that's similar to the program, but it should be less specific. So you're not detailing every specific step. This is kind of a higher level than you would actually get into within the programming environment. Okay, so let's look at the same examples we did for the flowcharts, but now written out in pseudocode. So here we have an example of linear pseudocode, where we're simply implementing the same thing that we did in the linear flowchart. So we get our input value from the user, we convert that temperature value, we display the temperature value, right? We're writing it out now instead of putting it in the graphical form of the flowchart. So next we have the same one, now introducing our decision into the process. So we're now asking the user whether we want to do Celsius to Fahrenheit or Fahrenheit to Celsius conversion, right? We can see the same type of structure that we had with the flowchart, where we get our input value, we get the conversion type that the user wants to perform, and then we have something to decide whether we're doing Celsius to Fahrenheit conversion or Fahrenheit to Celsius conversion, and we just display the result at the end. But you can see that this looks a little bit more like what you would actually see in MATLAB, even though we're not actually writing MATLAB script, whereas the flowchart that we saw before kind of gives you a graphical picture of how things are going to be occurring within the algorithm. And last but not least, we have the version that has the repetition in it so that we can convert multiple temperatures. Again, the main part in the middle here is the same as what we saw in the previous version. Okay, but now we have this while we're not finished, and then we ask the user at the very end if the user is finished. Okay, and we can see again, we're using indentations and things like you would see in MATLAB to kind of help structure this. And it's very similar to what we would actually be doing in MATLAB, but we don't have the actual MATLAB syntax here. We're focusing more on the development of what we're trying to do. Okay, so that brings us to the end of this video. Hopefully you've learned some techniques you can use as you're trying to plan your programs and moving from the problem statement into an actual MATLAB solution.